One of the most powerful laws in physics is the law of momentum conservation. For a collision occurring between object 1 and object 2 in an isolated system, the total momentum of the two objects before the collision is equal to the total momentum of the two objects after the collision. The purpose of this lab is to demonstrate conservation of linear momentum in one-dimensional collisions of objects and to compare the properties of elastic and inelastic collisions. Momentum is calculated by multiplying the mass of an object times the velocity of the same objects. In this experiment, we calculated the total initial momentum, the total final momentum, and the percent difference. Equipment: Pascal dynamic system, dynamic torque mount, rotary motion sensor, experiment resource, mass, cart breadth, cart flow, on-site workshop, 750 interface. An inelastic collision occurs when two objects collide and do not bounce away from each other. Momentum is conserved because the total momentum of both objects before and after the collision is the same. In an elastic collision, both momentum and kinetic energy are conserved. An inelastic collision is such type of collision that takes place between two objects in which some energy is lost. In the case of inelastic collisions, momentum is conserved, but the kinetic energy is not conserved. Most of the collisions in daily life are inelastic in nature. The total momentum of the two cars before the collision A is the same as the total momentum of the two cars after the inelastic collision B. When two objects collide under inelastic condition, the final velocity with which object move is given by V2 equal M1 over M1 plus M2 times V1.
All right, this is experiment number 9 in elastic collision. You see, this is a red car, this is a blue car, and these two cars, I will keep that initial velocity 0, and this car I will give initial velocity, and this car will travel and collide that one, and after collision both will stick together. Okay, I start this car and with some velocity v. Look, after collision these two cars are moving together and they travel some distance. So computer records the data. Here is velocity and this is time. So collision occurs here. We can highlight this and read the velocity here, right? 0.5 meter per second. The unit here is meter per second. This is the velocity little less than 0.5. Okay. Now here, this is the car, red car, which I gave velocity initial. The other car initial velocity was 0, but collision happens here. This moves after collision with velocity 0.15 meter per second. I mean, of course, both cars are moving together, so this is the velocity of the two cars. That is, mass is m1 plus m2. And mass of the car will be given to you. And mass of the car is 266 grams.
Using the velocity versus time graph on the computer, find the velocity of the car just before and after the collision. Also, it might be helpful to expand the graph to see just that area you are interested in. The first case of the mass of the car is equal, and you must now complete the table. P2, momentum of car 2, momentum equal mass times velocity. K2, kinetic energy of car 2, kinetic energy equal half mass times square velocity. And the last column must be get out the total of momentum and the total of kinetic energy. Elastic collisions are collisions in which both momentum and kinetic energy are conserved. The total system kinetic energy before the collision equals the total system kinetic energy after the collision. If total kinetic energy is not conserved, then the collision is referred to as an inelastic collision.
Car will collide with the other car with some velocity, and you see the other car starts moving, which was not moving before. So the velocity of the first car you can read off from here, 40 and 50, about 50 or 55 actually meter per second, and the velocity of the second car you can read off from here. This is the place collision happens. So and then you can calculate. You have to look tables of your part 3, and we are using equal masses. Do not use the table of unequal masses. Okay, over.
The velocity versus time graph on the computer. Find the velocity of cart 1 just before and after the collision. The vertical axis represents the velocity of the object. Also, it might be helpful to expand the graph to see just that area you are interested in. Performing the experiment, the following data were collected, and this data at the first case, the mass of the car is equal, and you should now complete the table. After performing the experiment, the following data were collected, and this data at the second case, the mass of the car is unequal, and you should now complete the table.